Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineer subscribers and viewers, as well as my students. Here are another problems in engineers in progress. I hope that you will develop through these problems. These are linear programming problems on optimization, but solved by algebraic way. So here is the first problem. Find the maximum and minimum values of the objective function f of x of y, f of quantity x comma y equals 3x plus 5y plus 2, where x is greater equal to 0, y less than equal to 2, and y is greater equal to x. So to answer this problem, we have to sketch graphs also. X is greater than equal to 0 is a vertical line to the right of the y-axis, which is this shaded part here. Then y is less than equal to 0 is a horizontal line below 2 units, this one. So we shade this part. And y is greater equal to x, or y equals x, is this line here where y is equal to x, the line that bisects the first and the third quadrant through the origin. So therefore, these intersections can be easily computed. Of course, this is 0, 0. When x is 0, y is 0. Of course, this is x is 0, then y is 2. Um, Based on the graph, based on the figure. And this is x is 2, then y is 2, because this is y equals x. And y cannot be greater than x, and y should be less than equal to 2. So therefore, we evaluate this part, and there are 3 points. The origin, I'll call that point 1, 0, 2.2, and 2, 2.3. So f1 equals, using the objective function, 3 times 0 plus 5 times 0 plus 2. So it is 2. F of f2 is 3 times 0, because x is 0, plus 5 times 2 plus 2. So it is 12, and f of 3, 3 times 2 plus 5 times 2 plus 2, that's 18. Therefore, the maximum value is f3, 18, and it occurs at 2, comma 2. And the minimum value is equal to 2, and it occurs at the origin 0, 0. So that's it for that problem. Let's proceed to the next one. Find the maximum and minimum values of the objective function f of quantity x comma y equals x plus 3y minus 4, where 2x minus 3y plus 2 is greater equal to 0, 4x plus y minus 10 is less than equal to 0, and x minus 3y minus 9 less than equal to 0, 3x plus y plus 3 greater equal to 0. So first, to plot, these are just lines. To plot, you set x 0, then solve for y, then you set y equals 0, solve for x. We only need 2 points because these are lines. So this would be the graph. When x is 0, y is 2/3. So when x is 0, y is 2/3, this point here. Then when y is 0, then x is -1. So this point here. So we then connect these 2 points, then extend, then that's the line 2x minus 3y plus 2 greater equal to 0. 4x plus y minus 10 is less than equal to 0. So let's sketch the graph here. When x is 0, y is 10. So it's above, not shown. And when y is 0, x is 10 over 4, or 2.5. 2.5 when x is 0. So this is 2.5 because this is already 2. Cannot be shown. The graduation is by 2's. Then connect. So this is the line 4x plus y minus 10 equals 0. When x is 0, y is negative 3, which is here. Then when y is 0, x is positive 9. There. We just extend, but connecting these 2 points, then this is the graph of the line x minus 3y minus 9 equals 0. Then finally, when x is 0, y is negative 3 here. And when y is 0, x is negative 1. So here. So connecting these 2 points, then extend. So this is the line 3x plus y plus 3 equals 0. Then we find these points of intersection between this line 2x minus 3y plus 2 equals 0 and this line 4x plus y minus equals 10. So this is at 2, 2. This is at 3, comma, negative 2. This is at 0, comma, negative 3. And this is at negative 1, comma, 0. But these points are, I just read it from the figure, but we can actually solve this by solving two equations simultaneously. For instance, for this point, for example, intersection between 2x minus 3y equals negative 2 and 4x plus y equals 10. So solving these two equations simultaneously using your calculator, because it is calculator aided, and if I solve this manually, the solution would be longer. So that's why you have to check it's at 2, comma 2. Next, for point 2, this is the intersection between 4x plus y equals 10 and x minus 3y equals 9. So solving these two equations simultaneously, we get 3, comma, negative 2, this point here, intersection between this line and this line. Sorry, it is the intersection between 4x plus y equals 10 and this line here, x minus 3y equals 9. For this point here, the intersection between x minus 3y equals 9 and this line here, 3x plus y equals negative 3. So solving these two equations simultaneously, we get 0, comma, negative 3 for point 3. Then finally, this point is the intersection between this line and that line there. So 3x plus y equals negative 3 and 2x minus 3y equals negative 2. So solving these two equations simultaneously, we have negative 1, comma, 0. We then evaluate the objective function at these 4 points beginning with 2, comma, 2. So f1 is 2 plus 3 times 2 minus 4. So f1 is 4. f2, which is this point here, x is 3 plus 3 times negative 2 minus 4, negative 7. Then f3, 0 plus 3 times negative 3 minus 4 is negative 13. Then f4 is negative 1 plus 3 times 0 minus 4, so negative 5. Therefore, the maximum value is 4 and it occurs at 2, comma 2. And the minimum value is equal to negative 13 and it occurs at 0, comma, negative 3. So that's it for this problem. Let's proceed to the applications. Problem 8. A manufacturer produces three types of products in 930 hours. Product X requires 5 hours per unit, product Y requires 7 hours per unit, and product Z requires 3 hours per unit. The profits per unit are $60 on X, $85 on Y, and $35 on Z. She has orders for 38 X units, 45 Y units, and 100 Z units. If she can sell all she can produce, what combination should she produce to make a maximum profit under the assumption that she cannot produce more than 150 X units or more than 60 Y units? So we have here the objective function based on profit. So we have 60 dollars per unit profit for product X. So that's why the total profit for product X is 60X, product Y 85Y, and product Z 35Z. That's the objective function, and we're going to maximize that with the following constraints. So 5 hours per unit in producing product X times X plus 7 hours per unit times Y plus 3 hours per unit Z, and it should be less than equal to 930 as mentioned here. And we also have orders for X 38 to a maximum 150, then Y should be less than equal to 60. Therefore, if X is 38 and Y is 60, so we have to shade this region here. Uh, this is X, this is for X 38, and we shade the right. So therefore, the intersection with Y is greater equal to 45 is 3845. This is 3860. This is X 150, Y is 60 if possible. And this is 150, X is 150, Y is 45. So when we solve for Z, it exceeds 100. So the value is 106. So that's why we add up 100, because the order is 100Z and there's no mentioned uh, the maximum value of Z. This is just the order. So Z is 106, so that's why we add up 100, the orders. So 60 times 38 plus 85 times 60 plus 35 times 100, that's $10,000, 880. But when Y is 60 and we set Z is 100, if we solve for X should be as much as possible. We maximize Y because it is the most expensive product among X, Y, and Z. So that's why we maximize Y to be at 60 units, so that we are guaranteed that the profit could be maximum. So when Y is 60 and we set Z is 100, then if we solve for X is less than equal to 42, so X is 42. So when X is 42, 60 times 42 plus 85 times 60 plus 35 times 100, we obtain 11,120, which is greater than the first. Therefore, uh, when when we set X is 150, Y is 60, if we solve for Z, Z would be negative, which is not possible because uh, the manufacturer has order of 100 Z units. So it is impossible it's negative. Therefore, we finalize the answer as the maximum profit is $11,120, and that happens when X is 42, Y is 60, and Z is 100. So this is the combination of products X, Y, and Z to be produced respectively, so that we obtain this maximum profit. Then lastly, a snack bar cooks and sells hamburgers and hot dogs during football games. To stay in business, it must sell at least 10 hamburgers but cannot cook more than 40. So meaning to say, for hamburgers or burgers, 10 is less than equal to B and B is less than equal to 40. It must also sell at least 30 hot dogs but cannot cook more than 90. So 30 is less than equal to D and D less than equal to 70. The snack bar cannot cook more than 90 items total. So that means burgers plus hot dog should be less than equal to 90. That's the constraint. The profit on a hamburger is 33 cents and on a hot dog it is 21 cents. So the objective function therefore to maximize profit is 21 times hot dog plus 33 cents times number of burgers to be produced. So what is the maximum profit? The maximum profit should be away from the origin in this region. So we set for the vertical axis, we have the burgers, hot dogs, horizontal because the snack bar cannot, uh, it must sell at least 10 hamburgers, this horizontal here, burgers, and cannot cook more than 40. So we have this boundary here, 10 and 40 for the burgers. Then for the hot dogs, 30 to 70. So of course the intersection between 30 and 10 is 30-10, but I'm not uh, labeling this because definitely it is not the maximum value. It is close to the origin. So next, this one, this point is at X, uh, hot dogs 30 and burger should be 40. And this one is hot dog 70, so burger 10. And that one is hot dog 70, burgers 40, but this is out of the region because of the constraints here. 70 plus 40 is already 110, so it is outside this constraint. So that cannot be possible. So we plot this B plus D equals 90, intercepts 90 there, then 90 also here. So when it intersects with X equals 70 or hot dogs equals 70, because of this line here, then if the number of hot dogs is 70, then burger should only be 20, 90 minus 70. So that point is 70 comma 20. And when the number of burgers to be produced is 40, then D is 90 minus 40, so it should be 50. So hot dog should be 50 and burger should be 40. We only evaluate these 2 points because definitely this will give either of these 2 points will be the number of hot dogs and burgers that will maximize the profit because of greater number than these two closer numbers. So we try at 50 comma 40 first. So the profit is 21 times 50 plus 33 times 40, and that is 2,370 cents or $23.70 or divided by 100 because that's cents. Then at 70 comma 20, 21 times 70 plus 33 times 20, that's 2,130 cents or $21.30. Therefore, this is the greater value. So sell 50 hot dogs and 40 burgers, hamburgers to get maximum profit of $23.70. So that's it for this problem.